Nvidia just revealed a new type of AI robot that can train itself before ever entering the real world. This means robots could soon learn how to work inside factories, warehouses, and industrial environments without needing constant human programming. And this is where things start to get a little concerning. Because if robots can train themselves faster than humans can teach them, the pace of automation could increase dramatically. Right now, one of the biggest limitations in robotics is training. Engineers need to carefully program machines, test them in real environments, and constantly adjust their behavior. That process takes time, it takes resources, and it slows down how quickly robots can be deployed. But what Nvidia is doing changes that completely. The company is working with ABB, one of the largest industrial robotics companies in the world, to build robots that learn inside virtual environments before operating in real life. This concept is known as simulation training. Instead of teaching a robot step by step in the real world, engineers can create a digital environment where the robot can practice tasks millions of times. Inside this simulation, the robot can make mistakes. It can fail. It can try different approaches. And most importantly, it can learn at a much faster speed than it could in reality. Because in a digital environment, time can be accelerated. A robot could train for weeks or months, in just a few hours. This changes everything. Imagine a robot learning how to pick up objects, move materials, and operate machinery, not by trial and error in a real factory, but inside a simulated world where it can practice endlessly. By the time it enters the real environment, it already knows what to do. And that is exactly the goal of this new system. Nvidia is building tools that allow robots to train inside highly realistic simulations powered by artificial intelligence. These simulations include physics, lighting, object interactions, and environmental variables. The robot is not just learning abstract tasks. It is learning how to operate in environments that closely resemble the real world. But here's where things get even more interesting. These robots are not just following fixed instructions, they are learning behaviors. Instead of being programmed line by line, they are trained using AI models that can adapt to different situations. This is a major shift from traditional robotics. For decades, robots have been extremely precise but limited. They can repeat the same action perfectly thousands of times. But if something unexpected happens, they often fail. If an object is slightly out of position, the robot might not know how to react. If the environment changes, the robot may need to be reprogrammed. That's why many robots are still confined to controlled environments. But AI changes that. With machine learning, robots can begin to recognize patterns, adapt to new situations, and adjust their behavior. And when you combine that with simulation training, something powerful happens. The robot can experience thousands of different scenarios before ever entering the real world. It can learn how to handle unexpected situations. It can adapt to changes. It can improve over time. And this is what Nvidia calls physical AI. Artificial intelligence that doesn't just exist in software, but interacts with the physical world. Now think about what this means for industries like manufacturing and logistics. Factories rely heavily on human labor for tasks that require flexibility and decision-making. Warehouses require workers to handle unpredictable situations. Construction sites are constantly changing environments. These are areas where traditional robots struggle. But if AI-powered robots can learn through simulation and adapt to real-world conditions, they could start entering these industries at a much larger scale. And this is already starting to happen. Companies like Foxconn are reportedly testing systems that use simulation-trained robots. These machines are being evaluated for real-world deployment. The goal is to create robots that can be trained quickly and deployed efficiently. And if that works, it could dramatically reduce the cost of automation. Instead of spending months programming and testing robots, companies could train them in simulation and deploy them almost immediately. That kind of speed could transform entire industries. But this also raises an important question. What happens when robots can learn faster than humans? If machines can train themselves, adapt to environments, and improve over time, the gap between human workers and machines could start to close. And that's where things become more complicated, because automation has always followed a predictable pattern. First, machines replace simple, repetitive tasks. Then they begin handling more complex operations. And eventually they start affecting a wider range of jobs. We've already seen this with manufacturing and industrial automation. But AI-powered robots could extend that trend into new areas: warehousing, logistics, construction, even certain service industries. But before we jump to conclusions, it's important to understand that this technology is still developing. Simulation training is powerful, but it's not perfect. The real world is unpredictable. Objects behave differently. Conditions change. Unexpected variables appear. Engineers must ensure that robots trained in simulation can handle these real-world differences. That's why companies are working on something called simulation to reality transfer. This means taking what a robot learned in a virtual environment and applying it successfully in the real world. It's one of the biggest challenges in robotics today. But progress is being made. Simulations are becoming more realistic. AI models are becoming more capable. And the gap between virtual training and real-world performance is slowly closing. And that's why this Nvidia development matters. Because it suggests we may be entering a new phase of robotics. A phase where machines are not just programmed, but trained. A phase where robots don't just follow instructions, but learn behaviors. And a phase where automation could scale much faster than before. But there's one more layer to this story. Because Nvidia is not just building hardware, the company is creating an entire ecosystem for AI and robotics. From powerful processors to simulation platforms to AI models, Nvidia is positioning itself at the center of this transformation. And if simulation-trained robots become widespread, Nvidia could play a critical role in enabling that future. But the bigger question remains: if robots can train themselves, adapt to real-world environments, and perform complex tasks, how far can this technology go? Will robots remain tools that assist humans? Or could they eventually take on roles that were once considered uniquely human? Right now, we're still in the early stages, but the direction is clear. Artificial intelligence is moving beyond screens and into the physical world. And once machines begin learning how to operate in that world, the possibilities expand dramatically. The only question is how quickly it will happen, and whether we're ready for it.